When you're walking to the classroom today, just like every casual day, have you ever wondered how your body, your legs, your feet, and your joints are working to help you maintain balance? Have you ever wondered what would happen if some of the joints are broken? Hi everyone, my name is Edward Chen, and I work for Plug-in Gate Optimization Lab in Penn State Mechanical Engineering Department as an undergrad research assistant. This project mainly targets to explore humans' walking behaviors and find correlations among plug-in gate joints when people are walking. My research lab mainly focuses on using exoskeletons to better help people walk, especially for those who are having disabilities. Before this semester, my work in this lab was mainly processing the kinematics data of the research subjects from the lab's motion capturing data. This process is done by exporting marker data into a software named OpenSim and use the model in the OpenSim to figure out what the motion and the joint angles of the research subjects. And one thing interesting I found when I was processing those data is that each person's joint angles are very closely correlated to each other. Which means that by having the same brainstem function, muscles, bone structures, terrains, and probably mood, we can probably expect an almost identical walking behavior. And your joint movements and angles can probably be predictable. After finding this out though, I didn't proceed on immediately since I had to keep doing other data processing works. However, after I learned machine learning techniques this semester, I found out that maybe I can try to use machine learning tools to first find out if there are correlations between the joint angles. And fortunately, after some time of coding and running the neural networks, the results turned out to prove that I'm right. There are unique correlations among the joint angles for each person. At the beginning of this code, I imported a human subject's trial data. Well, that's actually me. Then I used the knee angle and hip angle of my walking trials as input and the ankle angle as the output, trying to see if there are correlations between them. Notice that since there are a large amount of data given in a neural network, I used a relatively large neural network size. And here comes the important part I want to introduce to our classmates. If your computer is equipped with an NVIDIA or AMD ROCm supported graphics card, you can actually use graphics card instead of your CPU to train neural networks. This is very important, as this option can largely reduce our time needed to train a large neural network and be more thermal friendly to your overheated CPU. GPUs compared to CPUs are using relatively large processing bandwidth and are much more better in parallel computations. And therefore, they are much more efficient for performing machine learning, especially for those large neural networks built for deep learnings. The reason of why I bring this up are: 1. I want to save your CPU, especially those inside of laptops, from overheating. 2. Dr. Yang didn't tell us these useful techniques, which is very crucial when you want to train a big neural network in real life. And 3. I want you to know that graphics cards are not just for gaming and Bitcoin mining. They can be used to improve our life. Here, to better show you how GPUs can beat CPUs in neural network, I compared my GTX 1060 with my Intel i7-8750H in a neural network with a size of 50 with the same inputs and outputs. And you can see here how GPU used only 35 seconds to complete this training, while my CPU, throttled to 90 degrees Celsius, needed almost 3.5 minutes to complete it. If you want, you can find some graphics cards in the market that are optimized for neural networks and deep learnings. That will be very helpful when you are building a neural network for a large company in the future. Okay, bring back to our topic. Here comes the results. Using the neural networks, the predicted ankle angle is very similar, or even sometimes overlapping the real data. Notice that since the results was given by OpenSim, and my lab is allowed with an approximately 5% error, it can be concluded that we can actually use neural networks to predict people's ankle angles from their knee and hip angles. And what's more interesting is that I used a neural network I trained from subject 15 to predict the ankle angles from other subjects. Though most of them shows different results, some features of the ankle angle data of other subjects are actually very similar to subject 15. Those results suggest that people are having similar but not identical walking behaviors. But the walking behavior for each person under specific environment is unique and predictable. And therefore, it is possible that we can use neural network in the future to build exoskeletons and help people with disabilities to walk. In the end, I want to say that I'm very excited at this moment about this discovery and will probably proceed on with some in-depth research about this topic in the future. Thank you for listening and have a good day.